you have on that? You don't have to do 23 through 27? Do 20 as an example, okay? Okay, 23. Okay, 23 asks us to find it says use the unit circle to find the values of the 6 trig functions for each angle, 150-degree angle. Okay, so we start right here. We're going to look at the unit circle. We're going to find 150 degrees. So here is 150 degrees right here, right? Okay, we're asking, first of all, we're going to do the sine first. So we're going to go sine of 150 degrees, then cosine of 150 degrees, then tangent of 150 degrees. I'm going to move those over here. Okay, so look at your unit circle chart. Here is 150 degrees, Easton, right here. And sine is equal to what? What did we define sine to be? The y value. And what's the y value right there? It's 1/2. Okay? It's 1/2. Okay? And then you look at the cosine of 150 degrees. There's 150 degrees again. And we're looking for the cosine, which is defined to be what? Okay, it's just x. You don't have to write x over 1, just x. The x coordinate, which is negative square root 3 over 2. Then it asks us to find the tangent of that. Well, the tangent is defined to be what? Not x over y, y over x. So it's going to be 1/2 over negative square root 3 over 2, which I need to simplify. How do I go about simplifying that? What do I do to simplify that? Say that again, Sadie. Times 1/2, the top fraction, by the reciprocal, which is negative 2 over the square root of 3, right? Okay, so 2's cancel out. 1 times negative 1 is negative 1, and 1 times square root of 3 is square root 3. Is that our final answer? No, why not? Because we have a square root 3 in the denominator. How do we get rid of that? We rationalize it by timesing the top and bottom by the square root of 3, and what do we get? Negative square root 3 over 3. So there's the tangent. Okay, now we got to find the cosecant of 150 degrees, the secant of 150 degrees, and the cotangent of 150 degrees. So cosecant's defined to be what? The reciprocal of the sine. So what's the reciprocal of the sine? Okay, the reciprocal of 1/2 is 2. Secant's defined to be what? No, it's defined to be the reciprocal of the cosine, right? Which would be negative 2 over square root 3. But what do we need to do with that? Rationalize it. How do I do that? Times the top and bottom by square root of 3. What do we get? Negative 2 square root 3 over 3. Is that right? Okay, so there's that answer. Okay, and then the last one, cotangent of 150 degrees is a reciprocal of the tangent. By the way, I don't want to take the negative square root 3 over 3 because then I have to rationalize it. I can go back over here. Remember back over here where we had the answer right there? We just hadn't rationalized it yet. Would you like to say hi to everybody?
Hello, class.
Thank you. You're going to be famous. You're going to be on YouTube now. Okay. All right. So we can take the reciprocal of that. What's the reciprocal of negative 1 over square root of 3? Negative square root of 3 over 1, which is just negative square root of 3. Okay? Any questions there? Sadie, we'll take care of that at the end. It says during class sometimes, so you don't miss a lesson. Okay. Any questions there? Number 20? Okay. Let's look at number 20. Okay, number 20 is asking us to find two values of theta for which sine of theta equals 0. Okay, what can theta be equal to? What's the possibilities that can be equal to? The sine of what angle is 0, in other words? We might have used x in algebra 2. What was using for algebra 2? I can't remember. Okay, Sydney, what is the sine function defined to be? Okay, but on the stuff. No, not your unit circle. Get your foldable out. You guys, everybody get your foldable out. Sine was was defined in right trigonometry to be opposite over hypotenuse. But on the unit circle, it was defined to be what? Y over 1, right? Which y over 1, it's just defined to be y, in other words. So did you have that written down? Oh, okay. We got to get that written down on your thing today. Okay, so I want you to ask Sydney, where is the y coordinate on this thing equal to 0? What angle? Well, okay, do you know what an x and y coordinate are, right? This is an x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate, x coordinate, y coordinate, all the way around, right? Which one has a y coordinate of 0? But what, this is either 360 or 0 degrees, right? What's another one? Where else? 180. So 0 and 180 are the two answers. For 0 degrees and 180 degrees, if you took the sine of 0 degrees, you'd get 0. If you took the sine of 1, okay? Coterminal with one of these two angles is going to work. Because where's the next 180 lands? Every time you go to an angle that's coterminal with one of these, you're going to land right here, and its y value is 0. Every single time. Do you see that? All we want to know is what are two angles that have a y, that when you take the sine of them, you're going to get 0. Well, sine's defined to be the y coordinate. Y coordinate 0 right there and right there. So any 0, 180, 360, 540, 720, and all the way, keep going around. Every time you hit one of those two, you're going to get an angle that is going to be coterminous. Okay? Any other questions? If cosine of theta equals 0, what is secant of theta? Okay? If cosine of theta equals 0, what is secant theta? Is that what it's asking? Okay. If cosine is equal to 0, okay, well, the only way that's going to happen is when the x, because cosine is defined to be the x coordinate, right? The x coordinate's 0 right there and right there, right? So in a 90-degree angle, the cosine of theta is 0, okay? Well, what is the secant defined to be? It's defined to be 1 over x. Okay, it's the reciprocal of cosine. So 1 over x would be 1 over 0, which is undefined. Okay? Okay? I think you guys need to practice this unit circle because it's really not that hard. All you have to know is that if it asks for a cosine of an angle, find the angle and what? And look at the x-coordinate. If it asks you for a sine, find the angle and find the y-coordinate. That's all you have to do. Okay, any other questions? Okay. Yes, we will have a homework assignment today. Okay? Okay. No, we're going to have one. What?
I bet he's gonna give us a homework assignment over the break. So there's no
I might. This is, after all, a pre-calculus class. So. This is after all. This is after all a college level class, you guys. Did you guys all know that? This is a college level class. Okay. I don't need it anyway. I'm still storing. I still got the storing. I'm still storing your last batch of cookie dough. So. She gave me cookie dough. I told her she owed me, and so she brought me cookie dough. All right. The back's getting better. Basketball on Monday. So. Okay, we got it. You guys were recording this, so we got to get back to. Huh? Okay, we're gonna move on. Lesson time, right? Okay, put your homework assignment away, and we will go to the lesson. All right, this is what we're gonna learn today, you guys. I wrote the objective over here. Today, you will learn the 6 trig. I shouldn't say definitions. I should say functions. Okay, today we'll learn the 6 trig functions of a non-unit circle and how to utilize them. Okay, actually, teaching you guys today is very quick, and if you understand the unit circle definitions of sine, cosine, tangent, secant, secant, and cotangent, then you'll be able to pick up on these really fast. Everybody get out your foldable. We're going to write some more on your foldable today. Okay. Let's say that we have a unit circle right here. What a great circle, huh? Okay. Let's say that's a unit circle. Okay, we know that to define, if I have an angle that I turn on this unit circle, such as theta right here, I know that the radius is 1. I know that this distance right here is y, and this distance down here is x. And so a point right here is x comma y, right? Okay, here's the question. What if my point's not on the unit circle? What if my point is out here somewhere? On a circle that's out here? What if my point is out here? How do we define that? Okay? Okay, this is how we define it. After we get through getting this right here, we'll write the definitions down on our foldable. Okay, here we go. Right here, you guys, here's my point. I can draw the y distance right there. We're going to call this y1. And I have the x distance right here. We're going to call that x1. Sorry. Need to erase that. We're going to call that distance x1. That's from here to here. Okay, so we form this right triangle right there. And using the Pythagorean theorem, how would I figure out this distance right here? Because it's no longer 1 like it was on the unit circle. Well, you guys remember the Pythagorean theorem? We'll call that the radius, okay, because that's the radius of a circle. Okay, and we can use the Pythagorean theorem because we have this distance here and this y distance and the x distance. And what we do is take the square root of both sides, and so r is equal to x squared plus y squared, plus or minus. Well, actually, we're always going to take the principal, so it's just going to be the positive of that. Okay? There's no numbers. This is abstract, but we're gonna practice with some numbers here in just a second, and you'll see how this works. Okay, so here is the definition. We're gonna use this to come up with the definitions of the trig function. We're gonna start with sine of theta. This is for a unit circle. Okay, how do you find the sine? Okay, what was the right triangle trigonometry definition of sine? No, the right triangle trigonometry definition. Opposite over hypotenuse. Okay, so here's my angle theta. What's opposite of this? Y1, right? What's the hypotenuse? R. Because remember we just defined the radius R. I'll put that up here, R. Okay, so the definition of this is Y over R. Okay, the only difference is what? What's the difference between this sine of theta, which is Y over R, and the other one that's Y over 1? The radius is another number other than 1, right? It is on a unit circle. Now we're talking about a non-unit circle. Okay, this is a non-unit circle. Okay, let's go to cosine. What is the definition of cosine in right triangle trigonometry? Adjacent over hypotenuse. So look at what side's adjacent to the angle. x1 and over hypotenuse, which is r, or we'll just call it x over r. Okay? I would probably write these definitions on your foldable. Okay? Right next to those other ones that we've written. This is for a non-unit circle. Okay, what's tangent defined to be? Y over x. Opposite over adjacent, right? Which would be y over x. Is this one any different than the one on the unit circle? It's exactly the same, isn't it? It's exactly the same as a unit circle. Okay, let's go to cosecant. What's the easiest way to get cosecant? Reciprocal of the sine. So what is it going to be? R over y. Instead of 1 over y on the unit circle, it is r over y, since we know that the radius is a little bit bigger than 1, or a little bit smaller, a non-unit circle. What about a secant? R over x. And what about a cotangent? X over y. Same as on a unit circle, right? So really that different? They're really not that different. The only difference is on a unit circle, the radius is 1. So it's the same thing. It's just that now we're going to have a different size radius. Okay? All right, now we're going to use those. That's all I'm teaching you new today. Okay, we're going to do some examples. We are going to do some examples now. Okay, we're going to do some examples. Okay, want everybody to stop whatever else you're doing, because some of you guys are still working on the last assignment or whatever else. And we're going to do this together right here. Okay? Find the values of the 6 trig functions for angle theta in standard position if a point with coordinates 5, -12 lies on its terminal side. What does that mean? What's the terminal side? Huh? Okay, everybody plot the point 5, -12. Everybody draw an xy coordinate plane and plot the point 5, -12. I am going to find okay, I'm going to plot the point 5 comma negative 12. 5, 1, 2, 3, 4, 5 comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be down here, isn't it? Okay, and it says that the point 5 comma 12, negative 12 lies on the terminal side. So what does that mean? What does that mean, Sadie? If it has a terminal side, what is it? It's an angle, right? Okay, it's an angle. Here's its initial side, right? And its terminal side is down here, right? But we are going to use the reference angle. Where would the reference angle be? The reference angle would be, remember what a reference angle is? You got it right, Bryce. It's between the terminal side and the x-axis. So where would it be? It would be this angle right here, right? It would be that angle. Okay. Now we are going to draw a right triangle. So we're going to draw a line straight up to the x-axis. You always draw your triangle to the x-axis. Never draw it to the y-axis. See, I could have drawn a triangle, right triangle going this way, but you never draw it to the y-axis. Okay. Do I know any of the lengths or dimensions of this triangle? I do. Which ones do I know? Do I know this distance right here? It's 5. I know this distance is negative 12, right? I don't know what the hypotenuse is, but could I figure it out? How could I? Okay, using the Pythagorean theorem. 5 squared plus negative 12 squared equals r squared, right? And remember, I already gave you the formula. We square root both sides already, right? So it's just r equals the square root of 5 squared plus 12 squared. Well, what is 5 squared, everybody? And what is 12 squared? 144. And what is 25 plus 144? 169. Does anybody know what the square root of 169 is? It's 13. Okay? Now, this is plus and minus all the way down. I didn't write them on there, but this is plus or minus 13. However, the radius is always going to be positive. Everybody write that down. The radius will always be positive. It will never be negative. Okay, so it's a positive 13. Okay, so now we just learned the 6 trig functions for a non-unit circle, and here it is. That's a non-unit circle because our radius is 13. It's not 1, is it? So this is a non-unit circle, so I can use those definitions to create my 6 trig functions. Yes, Jerica? Well, negative 12 squared would be a positive 144 because you're timesing negative 12 times negative 12, which is going to make it positive. If you put in your calculator as negative 12 squared like this, if you go negative 12 squared, it will actually give you a negative 144. To do it right, you have to put parentheses around it and square both like that. Is that why it's confusing you? Did you do that? Okay. All right, so now we're ready to name the 6 trig functions of this. So I'm going to call on some of you guys to see if we can get this. I'm going to call on Dylan. You got number 1, the sine of theta. What is the sine of theta? That is correct. Why? Tell everybody. Okay, it's y over r. Well, what's the y distance right here, you guys? Negative 12. This is the y distance, right? Here's the x distance, and here's the r distance. So he just did y over r, which is negative 12 over 13. Okay? Huh? Okay, I'm going to go to cosine. I'm going to ask someone else. Let's go with Eric. Five over what? 5 over 13. Why? Because it's x over r. X is 5, r is 13, x over r. Okay. I'm going to go with Parker. Tangent. Negative 12 over 5. Why? Because it is y over x. Okay, I'm going to go with Bryce on cosecant. It's what? And how did you get that? He took the reciprocal of the sine, which is 13 over negative 12. Okay, good. Or you could have used the definition of cosecant, which is r over y, right? Okay. Let's go with Kyla. What is secant? Secant of theta is what? 13 over 5. How did you get that? Say that again. The radius over x. Yeah, r over x. Okay, good. All right, let's go with Lydia. What's the cotangent? It's what? 5 over negative 12. How did you get that? What? Flip what over? The tangent. Took the reciprocal of the tangent function. Do you guys get this? Could you do a problem like that? Because guess what? There will be a problem like this on your test. There will also be a problem like this on your quiz next week. Okay? I would like everybody right now to turn to page 296, and with your shoulder partner, I want you to do problem number 9. I'll give you a few minutes. Okay. Sadie, what's the x distance here? 3. Okay. Lauren, what's the y distance here? Ramon, what's the radius? 5. Did you use a Pythagorean theorem, or did you know that was a Pythagorean triple? Yep, 3, 4, 5 triangle. He knew that was a Pythagorean triple. All right. Okay, so we've got the radius is 5, because 3 squared, in case you guys don't know, 3 squared plus 4 squared does equal 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25, okay? So in case you didn't know that. All right. All right, so we have to find now the 6 trig functions of this, okay? McKay, I want you to give me one of them. Anyone you want to choose and tell me what it is. Sine, cosine, tangent, one of them. Tell me what this value of that is. Okay, sine. What's the sine of theta? Here's theta. That's a good question. How did we get to this point right here? That's the point 3 comma 4, right? Did we went there by going x is 3, y is 4? This is x distance, right? Isn't that the x distance? Isn't this the y distance? So which one's y? Okay, which one's the radius? Okay, what's the sine of theta? 4/5. Okay. All right, Michaela. Cosine is 3/5. Why? Okay, because it's x over r, which is 3 over 5. Okay. Let's go, Jay. What do you have? Tangent's 4 over 3. Why did you get that? Opposite over adjacent, or y over x, right? 4 over 3. Okay? All right, Sydney, give me another one. How'd you get that? Hypotenuse over opposite is the correct answer. Because the hypotenuse is r and the opposite is y. Okay? All right. Jenny, give me another one. Is what? 5 over 3. Okay, how'd you get r over x? Or the reciprocal of cosine, right? Okay. Jonathan, what's the last one? Cotangent. Huh? Why? Good. Okay, it's a reciprocal, all right? Okay, everybody understand how to do those? Okay. Now, here's the other kind of problem you need to know how to do. This is the last thing I need to teach you how to do. Suppose theta is an angle in standard position whose terminal side lies in quadrant 3. Where's quadrant 3? You need to draw time of this, you guys. It just will make a big difference. So, quadrant 1, quadrant 2, quadrant 3, right? And quadrant 4. So, the terminal side of this angle lies in quadrant 3. I'm just going to draw a terminal side of an angle in quadrant 3. Now, keep in mind, you guys, this angle turned all the way around right here, right? We want the reference angle. Where would the reference angle be? Between the x-axis and this terminal side, right? So this is the angle we're going to be working with, theta. And then I can drop to the x-axis, I can drop a straight line to make a right triangle. It doesn't matter where, we're going to draw a picture, and we don't know what the values are yet. So we're just drawing a right triangle in that quadrant, right? Now it does give us a hint right here. It says if sine of theta equals negative 4/5. So it already gives us the sine of theta. Equals negative 4/5. That's going to tell us two things out of x, y, and r. It's going to tell us. Sine is negative. And what's r be? There you go. Radius is always positive. So everybody's going to write this down. The radius is 5. The y value is negative 4. How are we going to find the x coordinate? Pythagorean theorem. X squared plus y squared, which is negative 4, equals r squared, which is 5 squared, okay? Is this the same thing as a 5, 4, 3? What do you think? 3, 4, 5, you mean, triangle? Yes, it is. Since the hypotenuse is 5 and one leg is 4, the other one has to be 3. The question is it, if I minus 16 from both sides, is it going to be positive or negative? Because I'm going to take the square root of this, and it's going to be plus or minus 3 is my answer. Yeah, it went this way. Which way is that? That's negative. Important to know. That was the best question a seniors asked me all year long. Okay. All right. Do you want me to tell you the names? Okay. All right. Okay, so we now we have them all. Can we finish this off? Can we find the what's the cosine?
Wait, hold on. I'll show you. Oh, I haven't done it. -3 and 5.
-3, 5. -3, 5, like
Over 5.
-3/5. Okay.
The dog.
Okay, why is that?
Because it's x over y.
It's not
Or
a x over r. So x is -3, r is 5. Okay, what is the tangent, Jerica? -4 over what? Over -3, did you say? Okay, what happens? What happens when you have -4 over -3? What do you get? +4/3, right? I'm fitting it in there. Okay, let's do the last couple real fast. Cosecant, everybody, what is it? We'll just write it as -5/4. Secant, what is it? -5/3. Cotangent, what is it? 3/4. And we're done. We just took the reciprocals of all those, right? That is how you do a problem like that. Can you do it? All right, I'm not going to have you do the last example. I'm going to give you the assignment. Here is your assignment. I'm going to turn this off in just a second, so if you're at home, pause it. The rest of you guys hurry and write it down. Never mind, we got to do the unit circle. Okay, yes. I've got to do this because some people aren't going to be here. What? But I'm doing this for you because you're not going to be here on Tuesday and Thursday. Oh, you got it memorized? But do you have it memorized still? Okay, run. Sadie, it's up to you whether you want to watch this and then go or go right now. Okay. All right, here we go. I'm going to teach you how to do the degrees first. Okay, you're going to have to pay attention. Everybody needs, oh, right over here, there's blank unit circles. Will someone run from each table and hand them out? Blank unit circles. I want you to fill them in as we go. We are taking, you guys, test, a quiz on Tuesday. Everybody got that? 5-1, 5-2, and 5-3. We will also take the units on Tuesday. We'll take them both on Tuesday. That's what we'll do. It's a test day. Your finals day, okay? Okay, I'm going to teach you right here. This is how you do it, okay? What angle is this line coming out right here? 0 degrees. So everybody right here put 0 degrees. Okay? Now, this thing counts every 30 degrees. Okay, except for the 45-degree lines. So you're going to go 30 degrees. Then what's 30 plus 30? 60. So this one up here is 60. We'll skip the 45-degree lines. Then 30 plus 60 would be 90. Okay, we're getting that? And you just keep adding 30. Going around, except for on the 45-degree lines. Don't do the 45-degree lines in each quadrant. Keep going around. What would you get? And we write 0 degrees as 360 as well. Okay? Now, can you follow that pattern? Okay. Now, the only ones we don't have filled in for degrees would be the 45-degree lines. Well, we know that's first one's 45-degree angle, right? 45 plus 45 makes 90. We already have that one written in. And 45 plus 90 makes 135. So we write that 135 in. And 135 plus 45 makes 180. And then 180 plus 45 makes 225. And then 225 plus 45 makes 270. And 270 plus 45 makes 315 degrees. And then plus 5 makes 360. We're back, okay? So you can fill those in if you know that each angle is 45 degrees. Do you see how we filled all the degrees in knowing that these are 30 degrees each, multiples of 30 degrees, and these are 45, right? Can you do that much? If you can do that much, that's how many points so far on your quiz? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 points on your quiz. There's 64 points on your quiz, if I remember right, or 66 or something like that. That's a fourth of your points. Okay, now radians. We haven't talked about radians this year, but last year you should have learned about them in Algebra 2. Okay, this one is 0 radians. Okay, this one right here is pi 6, or 1/6 pi. Call it 1/6 pi. You need to memorize that one. Okay, it's like you have to have 30 degrees memorized, knowing that's 30 degrees. Then all the 30-degree angles going around that we just marked as 30, 60, 90, and so forth are multiples of these. So this is 1/6. The next one is going to be 2/6. 1/6, then 2/6, then 3/6, and 4/6. What does 2/6 reduce to, you guys? 1/3. So everybody put pi over 3. So the first one was 1/6, then 2/6, which reduces to 1/3 pi. So what comes after 2/6? 3/6. And what does 3/6 reduce to? 1/2. So we say pi halves. So let's review. 1/6, 2/6, which reduced to pi thirds, 3/6 to 1/2 pi, or pi halves. So after 3/6 comes 4/6 pi. What does 4/6 reduce to? 2/3. So 2 pi over 3. Okay. After 4/6 comes 5/6. So 5 pi over 6. That one doesn't reduce, does it? And then after 5/6 comes 6/6. Well, 6/6 is 1, so 1 pi. Okay, let's review. That was the 30-degree angle was 1/6. The 60 was 2/6, which reduced. 3/6, which reduced. The 120 is 4/6, which reduced. And then 5/6 is, and then 6/6. Can we remember that? What comes after 6/6? 7/6. And that doesn't reduce, but that's this one right here. Whoops. 76. 7 pi over 6. And then after 7/6 comes 8/6. But 8/6 reduces to what? 4/3. And after 8/6 comes 9/6. And 9/6 reduces to 3/2. So 3 pi over 2. And after 9/6 comes 10/6. Well, 10/6 reduces to 5/3. After 10/6 comes 11/6. So 11 pi over 6. And after 11/6 comes 12/6. And 12/6 reduces to 2 pi. Okay, we got that? Now, we still got to get the 45-degree angle. So this one's another one you have to memorize. It is pi fourths. Okay? So you need to know that that one's pi fourths. So really all you have to do is memorize the first two angles in both degrees and radians, and then remember the pattern. Okay, so that's 1/4, then 2/4, which reduces to 1/2. Then what comes after 2/4? So this one's 3/4. So 3 pi over 4. Then after 3/4 comes 4/4, which is 1. 4/4 is 1, so it's 1 pi. 4/4 pi. Then after 4/4 comes 5/4, so 5 pi fourths. After 5/4, 6/4, so 6 pi fourths reduces to 3 pi. We already got that. 3 pi halves. After 6/4 comes 7/4, so 7 pi over 4. And then 8 pi over 4, 8/4 is 2, and 2 pi. We're back there, okay? All right, there's half of your quiz. If you can do that much, there's half your points. Got it? Okay, now you're going to have to memorize these numbers right here. First of all, the coordinates should be easy. This is a unit circle. The coordinates. Where the unit circle intersects the angle, okay? The terminal side of the angle. So at a 0-degree angle, what is the x-distance? How far is it from the origin to there? 1. And how far up and down do you go? 0. So this is 1, 0. Let's go around to all the axes and do them. What about this one? Going up here, 90-degree angle. 0, 1, right? Because you went nowhere left and right, and then you went up 1 unit. So the x distance was 0, the y distance 1. Okay, next. Down here. What's this? -1, 0. What's this? 0, -1. Okay, so we got those. Okay, so if you have those memorized, you should be able to get them. I mean, you don't really have to, just think about where they are. It's a unit circle. So the distance going out is going to be 1. So you got to decide, is it an x distance or a y distance? Is it going negative direction or positive direction, okay? Positive this way, negative that way, Bryce and Kaylani. Okay. All right. This one right here. Okay, this one right here. Guys, if you did this triangle right here, the y distance is 1/2. In other words, it's halfway. I mean, it's half of 1 going from here to there. Okay? And this is square root of 3 over 2. So the x distance is square root of 3 over 2. The y distance is 1/2. You need to memorize that one. You need to know that one. Okay? Now the 60-degree angle is just the opposite. Because now you go over 1/2, and then you go up square root of 3 over 2. I always remember the longer one is square root of 3 over 2. The shorter one's the 1/2. Okay, so this one's 1/2, comma, square root of 3 over 2. And then the 45-degree angle, we know what that one is, right? They're both, x and y are both the same. What are they? Square root of 2 over 2 and square root of 2 over 2. You have to memorize those. However, the other 3 quadrants are going to be the same numbers of those. You just got to decide if you're going in a positive or negative direction. You got to reflect them over. So watch this. This one reflects over to here. Okay? But the x distance is negative, but the y distance is still positive. So it's -1/2, comma, square root of 3 over 2. Got it? Down here, this one is what? It's a reflection of that one over there, right? But it's the x distance is negative. Negative square root of 3 over 2, comma, 1/2. And what's the 45-degree one? 135 degrees. And positive square root of 2 over 2. It's those same numbers. It just reflected all those numbers over here to get that. Okay? We can do the same thing here. Reflect the second quadrant onto the third quadrant. But then what do we know about the signs down in the third quadrant? Both of them are negative. You went negative. You went left, so that's negative, and you went down, that's negative. Got it? Okay? So we've got that. Okay, you got this down, Sadie? Do you think you understand it? Okay. All right. This one right here is what? This one's going to be a reflection of this one. Negative square root 3 over 2, comma, -1/2. Negative square root 2 over 2, comma, negative square root 2 over 2. And This one right here is 1/2 comma square root 3 over 2. It's a reflection. This 240-degree angle is a reflection of the y up top of the 120-degree angle. They're both negative, sorry. Those are both negative. Okay, what about in the fourth quadrant? What's negative and what's positive? The first one's positive because we went in the positive x direction. The y is a negative, right? So this one's going to be square root of 3 over 2, comma negative 1/2. This one's going to be square root of 2 over 2, comma negative square root of 2 over 2. And this one down here is going to be 1/2, comma negative square root 3 over 2. And you've got all your points. Each blank on there is going to be 1 point. Can you do that for the quiz? If you practice, notice the other side. I would see how much you can do without looking. Okay? The other side of it is blank. So I would look, and you can practice on that side. When I give you the test, everything's got to be put away. I'll take these 2 unit circles down, and you have to be able to do it without memorizing. Okay? No calculators either. What?